There are a few factors on a moving car, such as air friction, rotational friction, energy efficiency, wind blows, hills, and so on. However, air friction becomes the main factor at high speeds. This is about the difference between energy and power associated with air friction and car speed. Energy is force times distance. If an object is being pushed in one direction, the energy applied to it is only the force pushing this object and the distance traveled. Let's say the same object is being pushed with the same force at 3 locations, such as in a vacuum, in the air, and underwater. In a vacuum, the object would continue to accelerate. In the air, the object would accelerate, however the object would reach a terminal velocity at a high speed. Underwater, the object will accelerate, however will reach a terminal velocity at a low speed. The object in these different locations will be moving at different speeds over the same distance. However, since the force applied is the same over the same distances, the energy used at each location is exactly the same. Power, on the other hand, is different for these circumstances. Power is energy divided by time. Since power is energy divided by time, we can see that power can be shown as force times distance divided by time. This is because power is energy divided by time, and energy is force times distance. We can now go further by showing this with velocity. The definition of velocity is distance divided by time. Since power is force times distance divided by time, we can show this as force times velocity. This does not include force divided by time based on division. If you have 2 times 2 divided by 2, the bottle will divide one or the other, not both. Now that we can see that power is equal to force times velocity, let's look back at the objects shown. If the object is being pushed in a vacuum with the same force, the velocity will continue to increase. This also means that at fixed points, the power applied to the object will continue to increase. The force remains the same, but since the velocity is increasing, the power used to push the object continues to increase. In the air, the object will accelerate at the beginning, however it will reach a fixed point of velocity. Once the object is at a fixed point, the power will remain the same. The force will remain, and the velocity has reached a point to remain the same. So once the velocity is fixed, the power will stay the same. Underwater, the object will also reach a fixed speed, but lower than in the air. Power is force times velocity, so underwater, the power applied to the object is lower than in the air. This is because the object is going slower underwater. The energy applied to the object in each example is exactly the same. Now, let's look at a racing car. We want to find out how much power is being used by the car, how much energy is used over a distance, and the force applied to it. There are a few factors, but this is focusing on air friction. The air resistance force applied to the car is based on the coefficient of drag, which is based on the shape of the car and is found by experiments. The area and the density of the air and the velocity of the car squared. If the other terms are fixed, then the force applied to the car to maintain its velocity against the air friction is based on velocity squared. If the car is driving at a certain speed, a certain level of force is used to maintain that speed against air friction. If the car is driving over a certain distance, then a certain level of energy is used up over that distance. Also, the power can be determined by divided the energy used up divided by the time it takes to cover that distance. Now let's say that the car will cover that same distance, but at double the speed. The force against air friction is based on velocity squared, so since the velocity has increased by 2, the force due to air friction will be 4 times greater. The power is based on force times velocity. Since the velocity is 2 times greater and the force is 4 times greater, power by the car against the air friction is 8 times greater. So if the car is moving 2 times faster, the air friction force is 4 times greater, and the power from the car against air friction is 8 times greater. This is why racing cars need powerful engines. The power against air friction is based on velocity cubed. If the power from the increased by a factor of 2, the car would only go 1.26 times faster. So air friction is a large factor at high speed.